Good day to you from Chem Help ASAP. In this video, we'll see an interesting reaction of an ether. The work in this video was published in the Journal of Medicinal Chemistry by a group led by Dr. Pamela Haile at GlaxoSmithKline in Collegeville, Pennsylvania. The citation is on the following slide as well as in the video description. In the upper left is our starter material for the GSK synthetic route. Note that it has an ether, this methyl ether. The synthesis then goes for 7 steps to get to the structure in the middle. A lot has happened in those 7 steps, but the methyl ether is still intact. That's the great thing about ether functional groups. They are tough, robust. At this stage, however, the GSK group needed to get rid of the CH3 group of the ether. Cleaving ethers is not easy. The typical conditions involve highly acidic, harsh reagents like BBr3 or HBr. The problem is really harsh reagents can do more than just cleave ethers. In a molecule like ours, other functional groups might also react during the CO bond cleavage. Fortunately, our ether is a bit special. This is an aryl ether, meaning one of the R groups is an aromatic ring. Methyl aryl ethers can be cleaved with very strong nucleophiles. The favored nucleophile for this type of reaction is a sulfur anion, a sulfide or thiolate. A sulfur anion is a big anion, a nice polarizable anion with excellent nucleophilicity. The sulfur anion can attack the completely unhindered methyl group and kick out the aryl oxygen as a leaving group. For the product, we'll just show that left-hand ring. And we'll hide the rest of the molecule. So this is an SN2 reaction. I admit, we never saw a leaving group like the one that we've drawn, this anion, in other SN2 reactions. This reaction works specifically because A, sulfur is a great nucleophile. B, the oxyanion of the leaving group is stabilized through resonance in the aromatic ring, and that electron withdrawing sulfonyl probably helps too. And C, the reaction has plenty of thermal help at 165 degrees. Addition of acid at the end of the cleavage gives us the phenol product. The GSK group elaborated the phenol into a new ether with the phosphorus group on the end. The final molecule is shown in the bottom right of the slide. This molecule belongs to a class of compounds called Kinase Inhibitors. Kinase inhibitors are normally used as cancer drugs, but this particular molecule is selective for a kinase, an enzyme, associated with inflammation pathways in the body. The final molecule is currently being evaluated as an anti-inflammatory in clinical trials. In conclusion, a group of GSK researchers used a methyl ether to hide the reactivity of an aryl oxygen. When the methyl group needed to be removed, the scientists used a thiolate nucleophile to reveal the OH group so that the synthesis could be completed with a new group. If you want to learn more about how the GSK scientists performed the chemistry or studied the biological activity of the final compound, then check out the reference on this slide or in the video description. Please subscribe, like, or leave a comment. Take care.